On the morning of November 20, 1980, Lake Peigneur looked harmless, a broad, shallow freshwater lake beside gardens and old live oaks in southern Louisiana. An oil crew worked from a drilling platform near Jefferson Island. Beneath them, however, another industry had carved enormous rooms through a buried salt dome. The lake was generally only about 10 feet deep. Far below its muddy bottom, miners had spent decades cutting tunnels through solid salt. The mine included multiple levels and immense passages supported by pillars. On the surface, drilling and mining seemed separate. Underground, their margins for error were separated by rock, salt, maps, and assumptions. That morning, the drill string suddenly became stuck. The crew tried to free it, but the platform began to tilt. They abandoned the rig. Below, miners heard strange noises and felt the mine changing around them. Water had found an opening into a place designed to remain dry. Once lake water entered the salt mine, the problem accelerated. Salt dissolves. Flow enlarged the opening admitted more water, and more water dissolved more salt. A small breach became a self-expanding drain. The lake was no longer sitting above the mine, it was pouring into it. A whirlpool formed around the drilling site. The platform disappeared. Barges, equipment, trees, and sections of shoreline moved toward the growing hole. Witnesses watched solid ground fracture and slide. The disaster no longer looked like an industrial accident below the surface. The landscape itself appeared to be collapsing. The miners faced the most dangerous part of the event underground. Floodwater could cut off shafts, destroy power, and erase familiar escape routes. Yet the mine had practiced evacuation procedures. Workers moved toward exits while the tunnels were still passable. All of them escaped. The drilling crew also reached safety. The event destroyed major equipment and transformed the lake, but it did not kill anyone. That outcome was not luck alone. Early warning, fast decisions, and rehearsed evacuation turned a potential mass casualty disaster into an extraordinary survival story. Lake Peigneur normally drained toward the Gulf of Mexico through the Delcambre Canal. As the lake emptied into the mine, its level fell so sharply that the canal reversed. Water from the Gulf began rushing inland toward the collapsing basin. For a short time, Louisiana had a waterfall where no waterfall belonged. The reversed canal dropped salt water into the deepening lake. The flow carried boats and barges with it. The shallow freshwater lake was being rebuilt in hours by water, gravity, collapsing salt, and the geometry of an underground mine. Around Jefferson Island, roughly 68 acres of land subsided or vanished. Gardens, roads, structures, and mature trees were damaged or lost. The mine flooded beyond recovery. The drilling rig and much of the equipment disappeared below the new lake surface. When the violent flow finally slowed, several barges that had been pulled under later rose again. The lake did not return to its old shape. Areas that had been about 10 feet deep now reached roughly 200 feet, making Lake Peigneur the deepest lake in Louisiana. The chemistry changed too. Gulf water had entered through the canal, while dissolved salt and flooded mine workings altered the basin. A freshwater lake became brackish. The accident did not merely damage an ecosystem, it replaced one physical system with another. Investigators could examine records, maps, drilling operations, and the remains of the site, but much of the decisive evidence was now underwater or inside a collapsed mine. The central physical chain is clear. Drilling breached the mine, water entered salt workings, and dissolution enlarged the connection catastrophically. The catastrophe demonstrates why separate technical systems cannot be managed as if they exist in separate worlds. The drillers understood wells, the miners understood tunnels, the lake connected both. When maps, boundaries, and underground geometry failed to protect that interface, one operation became the failure path for the other. Lake Peigneur is also a lesson about nonlinear disasters. The first opening did not need to be enormous. It only needed to admit enough water to dissolve more salt. Each second made the next second worse. Engineers call this positive feedback. Damage creates the conditions for faster damage. Today, the calm surface hides a radically different lake and a drowned industrial landscape. Lake Peigneur swallowed an oil rig, flooded a salt mine, reversed a canal, and changed from shallow freshwater to deep brackish water in a single day. Its strangest legacy is simple. Everyone escaped, but the lake itself never did.